I will attempt to pass a list item. Let's head to the tokenizer class, and on the tokenize method, I will paste in a tuple that I have already copied inside the block patterns array. I will add a list to the markdown string. I will console log the tokens array, and you observe that there is a new token whose type is a list item. I will add another list item to the list, and you can also observe that we get a second list item token. Let's attempt to pass this token. I will head back to the parser class to add a new method, parseList. This method will return an AST node. Inside the function, I will create a variable list stack, which is an array of objects where each object has an indent property, which is a number, and an items property, which is an array of AST nodes. It is going to be an empty array for now. I will create another variable, current index, which is equal to -1, and then I will add a do loop. Inside this loop, I will create a token variable that stores the previous token. I will create another variable indent, which is equal to the tokens.indent if it exists. Otherwise, the indent variable will be 0. Then I will check if the indent is greater than the current indent, not current index. My apologies for this bug. If this is true, then I will push a new object into the list. The stack will have an indent property, which is the indent variable, and the items property will be an empty array for now. And let me change the current index to current indent, getting rid of that bug, and I'm just going to set it equal to the indent variable. I will make another check. If the indent variable is greater than the current indent, then I will add a while loop that will run as long as the length of the list stack is greater than 0 and the indent of the last object in the list stack is greater than the current indent. Then I will create a new variable, completed list, which is equal to the last object in the list stack. And after doing so, I will check the length of the list stack to see if it is greater than 0. If that is the case, I will create a variable, last item, that fetches the last item from the items array of the last object in the list. Then I will push a new object inside the items array of the last object in the list stack. I will spread the last items properties into this object. Then the children's property will be an array where we will spread the children of the last item inside, and an object with the type property, which is list start. I will make sure to add this list start to the token type, and I will also add a list end to the token type. I will exit out of the while loop and the else if statement and set the current indent to be equal to the indent property. Now let's add a list item. This will be added to the items property of the last item in the list stack. We push an object with a type of list item, a children's property which is equal to the result of calling the pass inline method with the value of the token, and it will have an indent property which is equal to the indent variable. I will add a clause that will end the do loop. This loop will run first and only continue if we match a token whose type is a list item. I will add a while loop that runs while the list stack has more than one item, and then I will create a variable completed list which is equal to the last item in the list. I will retrieve the last item from the items array on the last object in the list stack. I will push a new object inside the items array of the last object in the list stack, and I will spread the last item's properties into this object. Then the children's property will be an array where we will spread the children of the last item inside, and an object with a type property which is list start, and a children property which is equal to the completed list.items. I return a node from the function whose type is a list start, and the children property is the items array of the first item in the list. Let's head back to the pass block method to make an update. If there's a match with the token of a list item, then I return a call to this.parseList to pass and return the list. If I run the app from the terminal and console log the result, you can observe that we get an AST, and inside this AST, you can see a node with a type list start and a children array with 2 items. Let's try to parse bold and italics from the markdown. I will update the token type property to add a new type bold and another type italic. Then I will copy the tuples for identifying and extracting a bold and italic token from the markdown. I will paste it inside the inline patterns array, which is in the tokenize inline method that exists on the tokenizer. This is because bold and italics can only be inline tokens that exist on either a heading, paragraph, link, or list. Let's head to the parser to make an update to the pass inline method. I will check if the type of the token matches bold. Then I will push a new node to the nodes array. Its type will be bold and the children property will be equal to the result of calling the pass inline method with the value of the token. I will also try to match an italic token in another case. And if there's a match, I will push a new node to the nodes array. Its type will be italic and the children property will be equal to the result of calling the pass inline method with the value of the token. I will run this from the terminal and you can observe that on the children of the first node, there is a node whose type is bold and it has its child node. Same thing if I look at the children of the third item, you can observe a new node whose type is italic and also has its children. We are almost done. What is left now is to compile this abstract syntax tree into HTML, and for that, we need to implement a compiler class. I will create a new file which I will name compiler.ts, and inside of this file, I will export a class compiler. I will first pause with this class implementation. I will head back to the index page. I will copy the parser into a separate file named parser.ts while ensuring that the token type, the token interface, and the AST interface are all exported from this file. I will also cut the tokenizer class, create a new file named tokenizer.ts, and paste that tokenizer class inside of this file. Now let's head back to the compiler class. I will declare a oneness property, which is a string array. I will initialize it to be an empty array for now. I will add a new method, escape HTML, which accepts a text, which is a string, and it returns a string. Inside this function, I will escape all dangerous HTML characters so hackers cannot hijack our application. I will implement another method, compile children, which accepts a node as the first argument. It also accepts an indent level argument, which is a number. This function will return a string. Inside this function, I will check that the node has a children property, and if not, we will just return an empty string. Otherwise, I will map through the children, and for each child node, I will create a variable compile, which stores the result of calling the compile node with the child node and the indent level. If the compile string includes a new line, then I return a string which begins with a new line, then the compile string and another new line and a space. Finally, I repeat the space by the number of indents and then I return the compiled string from the function. I will now implement the compile node method, which will accept an AST node as its first argument and an optional indent level, which will be equal to 0. If no indent argument is provided, the function will return a string. Inside this method, I will create an indent argument, which is a string that consists of a space separated by the number of indent level. Then I will add a switch statement that checks the type of the node. I will check if it is an heading element, and then I will return an HTML heading element where the heading number will be the node level and the value will be the result of calling the compile children method with the node itself as the argument and 0. I will ensure that I join the results from the mark method called on the compile children and trim all leading spaces. Back to the compile node method, I will check if the node is a link and return an HTML anchor element. Then I will compile the images into an image element with an src that is equal to the URL property of the node. If there is no match, then I will push a warning inside the warnings array or no node type during compilation. I will compile bold nodes to the bold element and do the same thing for italics. We will compile the list start node to UL element and call the compile children method on the list node to get the list items. But we are not done yet. We need to compile the list items individually, and for that, I will create a variable item content, which is equal to the result of calling the compile children method with the node and 0 as the indent level. I will obtain any other content whose type is not a list start from the children of the list item. Then I will create a content variable whose value is conditional. If the other content has a value, then we return a call to this.compile children with the node. I will ensure that the children of this node is the other content variable and 0 becomes the last argument. Finally, I return a string with an HTML list item element whose value is the content. I will also pass paragraphs, and for each paragraph, I will return an HTML paragraph element and the value will be result of calling the compile children method. you can observe that we get the compiled HTML string in the console. So that is it for our videos on building a Markdown parser from scratch. I hope you found it useful and interesting. Absolutely smash the like button if you learned something from the 3 videos we made on this particular topic. Ensure you subscribe to the channel so you can get access to all of our videos in the future as they drop. And I'm going to see you in the next one.